Buy you something? Drink, coffee, soda? No? Okay. Okay. When I talk about inferential statistics, I meant to say you need to know how to make hypothesis and then use CI value to calculate your population mean whatsoever. Alright? Now here comes the true meaning of estimation. Two kinds of estimations. Number one, point estimate. Number two, interval estimate. Let's go to number one, point. Point estimation means this. The second concept is interval estimation, this. So the whole concept is surrounding with 1 and 2. Alright? So the whole concept of biostatistics is about these two important parameters. So point means average. Alright? When you do your statistical analysis to get your sample average, then you ask yourself, is the sample average close to population average? Average. Close. Close means estimation. Average means point. So the meaning of point estimation means the average close to sample average close to population average. Finish. All right. This is the concept. One more time. How can you estimate, predict your data? Number one, making hypothesis for estimation. How do you make hypothesis? Two concepts: null hypothesis, alternative hypothesis. Right? And null hypothesis here. Say population. All right. Close to sample mean. All right. Sample. Radius equal. Null hypothesis must come with equal sign. H1, or say alternative hypothesis, cannot include double sign. Equal sign. Finish. All right. So those are opposite concept. H0 must contain equal sign. H1 cannot have equal sign. All right. Finish. So in other words, it can be like this way. All right. Equal or greater equal or less than equal. Same thing here. Not equal can be this or this. So three kinds of H0. 1, 2, 3. Three kinds of H1. 1, 2, 3. Finish. All right. One more time. You know my style. The concept of H1, H0 goes by words, statements. All right. The same concept with tables, with figures. So these three continuous slides are talking about same thing, null hypothesis. All right. One more time. This concept for null hypothesis, H1, H0, same as this one. Oh, by the way, hypothesis, there are three kinds of hypothesis tests. One tail, two tail. All right. But one tail includes two kinds: left tail and right tail. And don't worry about this right or left tail, because I told you already. I told you already last year, right? When you hear the statements like this, I accept H0. Don't listen to this statement. I accept H0. No way. You can say 100% accept. No. You only can say, I have confidence to accept this H0 for about 95% of confidence. Even say 99.99% of confidence to accept this. Yes, you can. Never ever say 100%. There's no such thing so-called 100%. 100% is for mathematics. 95% or 99%, even 99.99% confidence to accept this truth is so-called statistical data. So never ever say 100% of something. That's for math. I'm here to teach you biostatistics, not teach you math. You go to math department to learn math from those professors. I'm here to deliver the basic concept of biostatistics. So never ever say 100% acceptance or rejection. Only say 99.99% right. In other words, 0.111% wrong. Wrong means type 1 error. I will go over type 1 and type 2 error later. Alright? So one more time, one of the topics for this morning is experiment design. How to do experiment design. First step, making your hypothesis, which I'm showing to you right now. Second step, design. Afternoon section, ANOVA design, t-test design, chi-square design, and then collect your data. I will not show you how to collect your data. Alright? When you go to your master program, your professor, future professor, will teach you how to collect your data by using random sample method. And then, yes, I'll show you some to analyze data. I will help you to discuss, explain your data. That's the whole concept. All right? Only one thing I will not deliver, I will not teach you for today's lesson. This. All right? If you were my graduate student, I would. But you are not. So I have no obligation to teach you. All right? So, when you say, one more time, when you say 100% sure, or say 95% sure, 99% sure, you are talking about probability, acceptance. All right, 90% probability, reject. That's it. Never ever say 100% sure to accept or reject no hypothesis. Very important concept, right? If you say 90% accept, in other words, 10% is wrong. 10% is wrong, all right? Wrong, error, significant. Those are same words, same meaning of the words. When you talk about error, error means significant, means wrong, W-R-O-N-G, all right? Those three words with the same meaning, all right? So when you hear significance, means something is wrong, something is error, what we call the type 1 error. Type 1 error. By the way, there are 4 types of error. Type 1, type 2, type 3, and type 4. 4 types of errors. In my lecture, I only show you type 1 error. I will not show you type 2 error, 3 and 4. When you go to your, maybe you learn from your biostatistics instructors already. Last year or year before, 2 years ago, I don't know, all right? So your professor may told you already about the 4 types of error. But in my lesson today, by 4:30, I only show type 1, which is so-called alpha error. Alpha error, right here, all right? So alpha is error, is significant, is wrong. So when you see alpha, means, something is wrong. And this alpha called type 1 alpha, type 1 error, or say significant error. All right, and alpha error plus What's the unit for alpha error? What's the unit? Percentage. Alright? Alpha plus CI over C error is equal to 100%. So the unit for this and this is percentage. So when you say 5% wrong, 5% error, means 95% of CI or zero is right. So this is right. Okay, not okay. Okay, not okay. Plus together is 100%. So the unit for these two parameters is percentage. So read this here. Wrong, right. Mistake, okay. Alright? So 95% okay, 5% not okay. 95% okay, 5% not okay. Alright? So by statements, again, now watch me to show you magic. By statements, by figures, by tables. So those four sides are the same thing to deliver the important concept to you. Again, alpha and CI. So the meaning of CI is right here. In two treatment groups, blah, 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 blah. 95% of CI, or say 95% of CL is okay, but not cover the whole thing. How many percent not cover? 5%, right? So one more time. You remove this to here. One means 100%. One means 100%, all right? So there are most likely three confidence coefficients. What are they? 90, 95, 99. Of course, you can say 94, 89, 79, 88, 98, but no one uses that, only you. All right? So most people use three coefficients. 1, 2, 3. Finish. Medical science, 99%. Life science, like you, 95%. Social science, from economic department, from English department, they use 90% CI, I would say CL. Those are three important coefficients. All right? So one more time. This right there on the board equal to 50 plus 10. Let me show you two important terminology. Upper limit, lower limit. All right? 50 minus 10, 40, all right? 50 plus 10, 60. This is lower. Change it. Lower. Type error. Lower limit. The green color here, upper limit. I'm sorry about my typo, all right? I'm sorry, all right? So 40 is so-called lower limit of competence. 60 there is called upper. This CI range. Interval. Interval means there. Interval means range. Interval means range. All right? So, one more time. This and this, same thing. All right? Go home and count how many lines. Exactly 100 lines. 100 lines. 100 lines. I counted already. And read the blue line. Blue line covers the population mean right here. Population mean is 50.29. However, 5 samples do not cover population mean. All right, 5 samples. Which 5? 1, 2, 3, 4, 5. 5 samples. Each line here represents 1 sample. There are 100 samples right here. 95 samples cover population mean. However, 5 samples do not cover population mean. All right? And assume that your answer is right here. Right here. This and this. This and this. Alright? 40 and 60. 40 and 60. Here, well, that's literally speaking. 40 and 60 means this. Alright? 49 something. 52 something. And this is so-called lower limit, upper limit. Finish. Alright? So, lower limit is here. Upper limit is here. Covers your population mean. Same thing again. Your sample range, upper and lower, the range covers population mean. Lower limit, upper limit covers population mean. Then you accept null hypothesis. Alright? When you hear me say about hypothesis test, towards hypothesis test. Now give me a definition of hypothesis. Give me another definition about test. They are related, but they are different. They are totally different, but they are totally related. Hypothesis is a description without test. Hypothesis, you make hypothesis statement. Alright? You say something to the mean. Right here. Hypothesis, right here. Hypothesis. But if you mean equal or not equal, greater, less than something, you are making hypothesis, means you make statement about means. Now, your job is to test if it's true about equal, not equal. So, the most important concept here is test. Of course, hypothesis is also important. After you make hypothesis, then you test hypothesis. Now the problem is, how do you do your test? There are so many tests, so many. Alright? T-test, chi-square test. Hey, you know this already from me, ANOVA test. So, I'm going to start from T-test. Alright? So, two concepts, two levels, hypothesis, test. That's the end of this section, right? About the introduction of the CI, CL hypothesis test. Let's do student T-test. Let's do student T-test, all right? T-test. Who invented, who developed T-test? This guy, William Gossett, all right? T-test. Where did T-test come from? Where's T-test from? Where? From normal distribution. So, hey guys, when you hear I say normal distribution, you need to pop up something in your mind. Normal distribution, large sample size. All right, large sample size. All right, so the cut point is right here. T-test, normal distribution test. The cut point is sample size. If sample size larger than 30, then you use normal distribution test. Formula is there. And this gentleman here, no way. We have facing so many small samples, as small as less than 30. So we are not able to use normal distribution test. We should use T-test. Alright, so when you face the sample size, or say small sample size, the sample size is less than 30, then your first choice is not this formula. Your first choice is T-test. Listen to me. So when you deal with small sample size, the N means sample size. Sample size less than 30. Your first choice, actually number one choice, is T-test. Alright, what's That's what he said. That's what he said. All right. So he invented this formula. He invented this formula. All right. Test of what? T-test. Test of what? Test this. Is population mean close to sample mean? Population mean is here. Sample mean is here. All right. Population mean close. What does that mean? Close. Close. Close means subtract. How close you two? Boyfriend, girlfriend, close. How close? You subtract each other. If these two numbers close enough, the whole value here is equal to 0, or say close to 0. Close to 0 means a set. H0. Bingo. Bingo. All right. What about this? What about this? Sample error. This standard deviation divided by root number is called sample error. Why? Why? Because you only use small sample size. 10 students, 25 students. Those numbers are considered small population size. So you need to justify your formula by using sample error or standard error. Standard deviation divided by root n is so-called sample error or standard error. Right? So the whole formula is here. T equals to blah 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 blah. Here divided by sample error. All right. Oh, by the way, his name was William Goshen. How come he used nickname student T? The only reason was because his company did not allow any worker to write down any papers. No papers published. So he used student T as his nickname to publish 3 papers in his whole life. Number 1 paper, 1 sample t-test. Second paper, 2 sample t-test. 3 paper. The third paper, 2 sample t-test, but 2 sample paired up. The samples are paired up. You will know from it by 11 o'clock. All right. So 3 papers has been published by him. 1 sample t-test, 2 unpaired t-test, 2 paired t-test. So you will hear these 3 keywords from me the whole morning. 1 sample t-test, 2 sample t-test. What kind of test? Pair up t-test, independent t-test, blah 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 blah. Okay. So anyway, that's his nickname, student t-test. Initial for t-test. Remember, 3 kinds of tests. 3 kinds of tests with 3 different formula. He invented this formula right here. All right. 1 sample t-test use this formula. All right. 2 sample t-test and 2 kinds of sample t-test. One is independent t-test. The other one is paired t-test. Depends on your data relationship. I will show you. All right. So when you learn biostatistics from your lecturer last year, even 2 years ago, you have been through this ugly, super ugly formulas. All right. Today, do not learn this from me. No, learn SAS from me. Every single one has their own unique model in terms of SAS input. Different type of this t-test use different comments, SAS input comments. Very unique. Otherwise, I don't need to separate into 3 levels. 3 levels. What's wrong with this? Give me 1 more minute, please. All right. So anyway, 3 concepts, 3 formula, All right? And I'm going to start with the most easiest one sample t-test. All right? Either one comes from here, comes from this basic information. All right? Now read this basic information about the formula. Now use your pen. Write down here, population information, sample information, population mean, population standard deviation, sample number, sample mean, finish. So in order to get a t-value, you need to have 4 information. Which 4? Population mean, population standard deviation, sample average, sample number. Once you have 4 information, you will be able to calculate t-value. All right? You want to take a break? Go ahead.